Okay. Hi, everyone. Today I will be presenting versus comparison framework. Let's go through the agenda real quick. I will be talking about the biography of the authors, introduction, what is versus, why use versus, our test case structure, versus comparison modes, versus configuration file, the versus flow, versus reports, and finally, quick introduction on the versus UI. Okay. I'm Omar Ragy, software QA manager at Siemens Digital Industries Software. I have co-authors Ahmed Ali, who is senior QA engineer for Siemens, and Reem Al-Adawi, my manager, director of quality at Siemens Digital Industries Software. Some introduction on what led us to versus. We have large regression suites from few hundreds to few thousands of test cases. Very frequent code changes, very frequent regression failures, comparison failures. We've got so many non-standard comparison techniques, like everyone is using his or her own technique of comparing the output results versus the baseline. Time-consuming regression test analysis. When failures comes, it's very time-consuming to figure out why did it fail, and this so on a very frequent basis. We didn't have a very standard way to compare or ignore minor differences that might be acceptable in a regression suite. Okay, now back to versus. What is it and why use it? Versus is a comparison framework for abstracting the comparison process for automated regression suites. It supports many comparison modes suitable for many file formats. It uses a simple configuration YAML file to define the comparison that you want to make, and also the options or error tolerance that is allowed for each of the test cases. Why using versus? Versus is YAML configuration based, which is easy to use and easy to understand and also easy to maintain. No code writing required. You just declare the comparison mode that you would like to establish. And it's clear, and it has a clear and standard reporting. So whenever a failure happens, it's very clear where to look. Easy to debug the comparison differences, and less time analyzing the regression failures. Here is a simplified test case structure in our company. We have a test case. This is a folder. Under this folder, we have files and other folders. The baseline is the directory containing the expected output files. The to file is the shell script that invoke the application under test to produce the output files. This is a sample output. Here it's a simple text file. It's called out.txt, and it is outcome from the do file step. And we have a compare script, is a shell script comparing the output files versus the expected results. And going into this comparison step, as you can see, it's a simple shell script, Bourne shell, and it is calling only one command, which is versus, and given the versus one parameter, which is the YAML, and give it the configuration file. So this is where versus lies. It's inside the comparison step. Now we have the versus comparison modes. Versus framework support multiple comparison modes. It's basically a wrapper or an interface for a variety of scripts that are generally available for everyone, as well as your own comparison scripts. So these are the versus comparison modes that we have supporting so far. We have the diff mode, which is comparing files line by line. I believe everyone would know what is the Unix diff command. And we have the non-diff, which is based on diff, but it's line by line and also field by field. And it is very aware of the numerical, different numerical formats or small numerical differences. It works well with CSV files. So you can easily compare tables with non-diff. We have the operator mode, which is actually the Python comparison operators, equal, equal, not equal, less than, equal than, and etc. We have the scalar mode, which is number comparison. You are comparing one number versus another one, but this is different than the operator that you can specify some allowed tolerance for this mode. So you would allow differences up to maybe 5% or absolute difference like 1 or something. We're also supporting image comparison, comparing one image to another. Internally, we're using OpenCV and the Python SCI kit image to compare image. And this allows us also put some tolerance comparing one image to another. So we can take a screenshot of one output and compare it to a baseline. And this is how we can do the image comparison. And this guy is the XOR, which is typically an in-house tool that we have that compare one layer to another. So this is something related to the EDA domain, but it's not available for everyone. It's an internal tool, but this shows how much Versus can integrate to your own tools. So if you discover any other comparison technique you want to apply, you can easily integrate it to our Versus framework. And this is where you can add your own comparator.
Then just define another shell script call out, okay, define it.
Exactly.
It calls and has one method, standard interface.
Exactly. It's a standard interface where you can, for instance, if you want to compare voices or sounds, we don't support this today, but you can create your own and hook it to our framework.
Cool.
Okay. I'm explaining today the Versus configuration file. It's a simple YAML file. It has a major key, which is called compare checks. Compare checks is a group of comparison checks. So this one is hard-coded compare checks, and then you start put some names for your own checks. So we have here check 1, check name 1, check name 2. You can put here whatever you want. And for the mode and the metric and baseline, those are common in all checks. Mode, when you specify whether you want to check on text comparison, table comparison, or even image, this is when you specify one of the enums that we already support. Metric, this is the output files from the application under test. And the baseline is the files that you want to compare against, which is basically an output of an older or a good version of your software. You keep it in the baseline. So this is where you specify either your files or a query that would resolve to your own files. We have also mode parameters. This is completely dependent on the mode, and you can fine-tune the comparison that you are having, but by passing some simple or complex configuration. And those mode parameters are available and documented based on which mode you are using. So this is the standard configuration file. You can have a very simple one, and you can have an extremely complex one. So let's move on to explaining it more by having a real-world example. This is the diff comparison mode, which is basically the most basic diff, the most basic mode in the versus. We have the metric is the file.txt, and the baseline is baseline file.txt. So I'm here comparing file.txt in the current working directory versus the baseline and diff. This is where I'm telling versus I would like to those files to be 100% identical. If any difference in any of the files, this check will fail. Moving to another format, not for the diff files, but for the metric and baseline specification. Here you can specify an array of files. Instead of having single file, you can specify one array, and all the comparison will be done to the corresponding file in the baseline. So each file from the metric array would be compared versus the corresponding file in the baseline array. And the last thing that you can also specify a wildcard. So if you have, if you are comparing all the extensions for CSV or TXT to this, so you don't need to specify the file names. You can add a simple query, and whatever files in the baseline should be compared to the corresponding one in the outputs. So this is just to have a common way to define without hard coding the files dependent on the test case. Second one, I'm here explaining the non-diff mode, which you can compare one CSV to another. This mode is rich by specifying some absolute error tolerance or relative error tolerance. So if any of the fields differs within 13 as a value, it passed. If more than 13, it would fail. And same for this. I would allow 15% tolerance to any of the fields in both f3.csv file. So this is how you can have multiple checks, check 1, check 2, check 3 in the exact same test case. And we have also the conditional tolerance. You can specify if some environment is used tolerance, or if the operating system is whatever, allow another wider tolerance. So there is some advanced conditional error tolerance available to be used with non-diff. Okay, the scalar is pretty much straightforward. You are comparing a single value inside a file versus another value inside the baseline. It works well with the tolerance as well. So sometimes you would like to compare the current test runtime with the baseline runtime, or current memory consumption for a test case with the baseline and so on. And you can also mix and match. You can also use here baseline as a hard-coded value instead of a file. So you know that this result count should always be this number. No need to store it in a baseline or file. This one is interesting because you can compare one image to another, and you can also set some tolerance. Okay. So you can set the minimum image similarity score to be 90%. So you would put here 10% as a tolerance. So this is the error I would allow. This is an important tool that we have today in our EDA world, which is the file format here is something called Oasis format. I'm just presenting this to show you that you can have your own comparator integrated as we did here. You can specify the files that you want to compare, the mode that you want to add, and also put as many options as you want to your comparators. So you can, this is free form. You can put as many options as you want, and your comparison mode would process these parameters and do the comparison accordingly. This slide only to show you how complex you can go with parameterizing your comparator.
Can we mute everybody, please?
If you would like to call it. So this is XOR mode. We went so far by parameterizing the options that are available that say or teach versus how to do the comparison and to allow it some tolerance at a certain circumstances and narrow down the tolerance in other situations. So this is basically for you can control this by environment variable or tell it if you find yourself in an operating system or a device type that matches this criteria, please use the following tolerance. Okay, back to the versus flow. As you can see, as input, we have a single YAML configuration. It has all the configuration that is needed for the comparison step. And it has the output function query, files query, and the comparison checks and the corresponding configuration file. All these are the engine. But what about the output? What do I get after the versus processes all this data?
Can we ask to mute participants, please?
This is where versus is good at. Versus is good at producing some very comprehensive outputs and logs that will tell you
the babies are waiting for you.
Can you mute yourself, John, please?
That you have. And the severity of those
John,
your babies. They're waiting for you.
and of course a final step, whether all the checks were
Your babies in there?
statistics.
Yeah, I was
Let's
gonna
go
$60 to $30 for a bag of.
to
It was like a bag like that. It wasn't 5 pounds.
versus
It was like a
transcript.
3-pound bag.
This is the general view of the versus transcript. It tells you the configuration file that is being sourced, the environment variables that were set. This is typically the file inside the test case. This is where it is specified. You have the comparison checks reports.
That's not bad.
We will go through it into details in a minute.
Oh, that's pretty.
And we have a summary report comparison.
Can you tell the two right now,
all
immediately?
the checks,
2
what
cups of the
files
green
that have been
French green from the basement.
compared versus which files, and what were the comparison
downstairs.
checks, and the
We'll
status
do it
of
right
the check.
now.
And we have a final
So,
summary report
Need a couple
that
bites.
tells you the final
yeah, well, it's heating up.
of the
Here, take this. Wash this
comparison.
up. Take it. This
Let's
come back
go
and we'll
through
do 2 cups.
the
Bring that
versus
pan and wash it up.
comparison
Take it.
checks
Here's
report.
my
For each of the YAML checks, you will get a report
I'll take a little bit.
telling you
Thanks.
exactly the command line that have been used in order to do this kind of comparison. It also gives you colorful information regarding the status of the comparison mode. For this example, this is red. It says have failed, and please check this file as a hint. And if everything goes well, it will give you like pass and some hint regarding the comparison. As you can see, this is very standard. Each of the checks required to be implemented that way to give you a hint that explain to you the severity of the failures. And also you can use this hint can be used to assess whether this is a true failure or not. So this is very useful for us as everything is becoming standardized this way. The versus compare and summary reports. This is the table that has compare reports, check names, what files, what is the check type, and a final status, whether it is failing or not. And the summary report tells how many checks were executed, 3 passed and 3 failed, and this is the final status. And exit status of the script would be 0 if all passed, otherwise it would be 1. So Versus can integrate with other regression runners by communicating the final status by the exit status. As it becoming somehow annoying to write a huge YAML file, we did create a simple GUI to generate the Versus configuration YAML file. So whenever we introduce a new comparison mode, we would update this GUI in order to support creation of the YAML file through the UI. So now it's much easier to generate a YAML file by the UI instead of writing it by yourself. So all the options would be some entries. So whenever you change the comparison mode, all the corresponding options for this comparison mode would show as entry and some hints how to use it. Thank you. That's all, and I'm happy to hear your questions.
Some questions? I just asked to see if anybody have questions online. Anyone else? I have, okay, go ahead. Yeah, what do you have?
For the comparison, do they need to be two images?
Very good question. Actually, Versus works as an interface to whatever you find it suitable for you. So in case of you want to implement your own very smart image comparison and you find the best technique is the Python SCI kit or whatever, and it supports the similarity, no matter the size is, no matter the light intensity is, and so on, you can just plug in and integrate this to Versus. So Versus, basically, it's not about the tools that is behind it, but it's about the interface that you can put any comparison interface to it and still have the standard way of reporting and the clean way of assessing the final results. But for your question, yes, it takes care of the size and the intensity and so on. This is what we use.
There's an online question. It says, does it support comparing standard image formats like PNG? And does it create a diff image? It's a similar answer, similar question.
Yes, exactly. Yes, it does. And if it doesn't, it's very easy to support this functionality. So whatever binary or library that you are comfortable using it, and you believe it is doing its job for a faster regression analysis and faster assessment for the failures, let's hook whatever you have to Versus, and Versus will still use it for comparing and reporting in a standard format. But today, yes, this is the one that we are using it.
I've got one.
Yeah.
So maybe I missed something so in the past when you run Versus, it always refers to the baseline. So I basically set up, I do a run, and I think this is a good baseline, right? I establish that by setting the folders, 1,000 right folders, say this is the baseline. So how do I update? Are you assuming that? So how does that baseline get updated? Is it just external? Because I, as an external process, go, okay, the baseline should be updated, right? And then I change those update baseline files, and then Versus just uses those.
Exactly.
Am I trying to answer the own question?
Yes, exactly.
So who updates the baseline? It's an external entity, which is new.
Okay, it's actually the queue in our team. We update our baseline ourselves based on the recommendation of the R&D. If they believe that the baseline is new output is actually a better output and is causing a regression failures, we would update the baseline.
Right.
Yeah, just overwrite it. Yeah, we just overwrite whatever files in the baseline. And this is how we update. And that would be our new baseline for future comparison.
Cool, good. I have one more. This is a horrible question, forgive me. But do you Versus ever for fun, like the output of Versus the previous version?
You mean we are using, how do we test
Do you
versus?
have a new version of versus? Do you check the output of the old one versus the new
We,
one?
we are testing versus with
Yeah.
basic diff, only diff. So yes, we have a regression
You
suite.
can't trust versus, right?
Yeah, we have a regression suite for versus, which is basically we count only on the diff command.
Okay, well, that's a legitimate question. That was just,
Yes.
cool. I had one more quick thought. It's kind of fun. Like I think is you should just go into the diff command now in Linux and update it with these flags, right?
Yes,
Or have your own rebel.
exactly.
Yeah, those were not my two. It's awesome to see. I created a company before called Active, by the way. So I totally love diffing. And is it open source?
Yeah, I'm still discussing with the management.
Right.
Yeah, yeah, I'm still discussing. So we will see if we can open source it.
Cool.
Okay, thanks a lot.
About everything.
Thank you very much.
You're good? Cool.